Northern Rockies Heavy Equipment Task Force. The Heavy Equipment Task Force is only used in the Northern Rockies and was designed as a tool to be used for line construction in heavier fuel types. The design of the task force is to use a complete mechanical logging side to accomplish the task at hand in a more efficient manner due to the operators being used to working together. The job site foreman is responsible for explaining planned operations to the equipment operators and ensuring that best practices are followed and implemented during the operational period. Heavy equipment is being used at greater numbers every year by the wildfire agencies. The wildland fire agencies do not own much of this type of equipment, and in some areas do not have a lot of familiarity with heavy equipment and its capabilities. Ask questions of your equipment operators and learn from these experiences. As a heavy equipment boss, your job is to provide the equipment operators that are working for you direct support concerning fire behavior, weather conditions, and communications concerning the task at hand. The equipment operator that you are working with is a professional in their field of expertise. Listen to what they have to say, trust their instincts on what the equipment can and cannot do. Try and make sure that the crew and equipment is taken care of in the same manner you would take care of a fellow agency crew member. Everyone is working together to accomplish similar goals. Respect is reciprocal. Maintenance. Heavy equipment used to suppress and rehabilitate wildland fires are usually used in tough conditions, consisting of high temperatures, lots of dust, and rough and broken country. High horsepower machines burn a lot of diesel per shift. Ensure that the machine has a way to be fueled daily. Most logging attachments are powered by hydraulic fluid. Hydraulic pumps supply hydraulic fluid to the end of the boom through hard lines and hydraulic hoses. These hoses break during use and will need repair. Due to the rough country that these machines work in and the solid track frame that they travel on, daily maintenance should be planned to keep the equipment operational. Fueling will take approximately 20 minutes. Basic greasing and visual inspection of hoses and wear parts and cleaning of filters and pre-cleaners will take another 20 minutes per day. Work with the equipment operators on bringing an engine or water tender up to the site to wash down belly pans and radiators as part of the maintenance plan. The HETF, Heavy Equipment Task Force, will consist of one Heavy Equipment Task Force foreman, referred to as foreman. The foreman is the first man out of the door. He or she will meet with Plans Chief and Planning Ops, or IC, Incident Commander. If no IMT, Incident Management Team, is in place to help with the plan for Heavy Equipment Task Force, the foreman must know the planned objectives and the proposed time to complete the mission. The foreman must understand all safety concerns and make sure the task force is aware of the mission and safety protocol. The foreman will also relay the mix of equipment needed to accomplish the mission. It is also the duty of the foreman to do daily coordination with finance for time and invoicing. The foreman is handcuffed to Heavy Equipment Boss, or TFLD, Task Force Leader, which NWCG, National Wildfire Coordinating Group, is currently working on to become a STEQ, or Strike Team Equipment, or work with a DIVS, Division Group Supervisor for the entire assignment. The foreman is the technical expert, with the Heavy Equipment Task Force understanding capability, limitations, and production rates of equipment and operators. The foreman is the main supervisor of the equipment operators. HEQB, Heavy Equipment Boss, is the tactical supervisor of the Heavy Equipment Task Force and works directly with the foreman. It is the responsibility of the foreman to make sure the Heavy Equipment Task Force is not broken up to be used as individual pieces of equipment on different locations of the incident. That can only be done when the heavy equipment foreman agrees to do this, and the task force is disbanded, and each piece of equipment that is kept is then given a new E-number and resource order as a standalone piece of equipment along with individual HEQBs to monitor the work and provide direction. The foreman will provide his or her own four-wheel drive transportation, one leveling feller buncher, one rubber-tired skidder, one Type 2 dozer equipped with a 6-way blade, PAT, power angle tilt, or manual angle with hydraulic tilt, one drop tank skidgen or pumper cat that can also skid logs, and the transportation for the equipment to and from the incident. In addition, a second feller buncher, an excavator, or a boom-mounted masticator may be ordered in compliance with certain requirements. HETF must transport the leveling feller buncher, drop tank skidgen, and foreman to meet date and time needed on the resource order, and will be given up to 24 hours to transport the rest of the equipment to the site to complete the Heavy Equipment Task Force. 2 transports capable of hauling all equipment and designed for use on arterial Forest Service roads shall remain on site after initial haul-in of the equipment for the duration of the assignment. One of these transports will have a dedicated driver, while the second transport must be available, but one of the equipment operators may double as the driver of that particular transport. Once an order is placed and accepted by the vendor, incident operations may negotiate the following reconfiguration directly with the vendor. 1. Replace the dozer with excavator. 2. Add a feller buncher and/or excavator and/or boom-mounted masticator. The HETF shall not at any time exceed 6 heavy equipment components. Foremen and all operators shall demonstrate experience in timber harvest procedures and be capable of operating the machine up to the manufacturer's limitations. Each piece of heavy equipment and one of the transports must be fully operated. The second transport, as well as any additional retained transports required to remain, will be paid the awarded transport daily guarantee or mileage, whichever is greater. The second transport, as well as additional transports retained by the incident, are not required to be fully operated. The foreman shall work as a liaison between the assigned agency heavy equipment boss, HEQB, and the HETF operators to ensure the operational plan is understood and implemented under safe working conditions, ensure efficient use of equipment, troubleshoot breakdowns, and to provide solutions to potential issues as needed. The foreman will report to the HEQB and may be asked to participate in operational planning meetings. At no time will the foreman be considered the tactical supervisor of the task force. These duties will be performed by the assigned agency HEQB. This position must be capable of walking in rough mountainous terrain, must have expertise in forestry practices, and have a working knowledge of the awarded equipment limitations and heavy equipment operator qualifications. The contractor is responsible for all equipment, materials, supplies, transportation, lodging, trained and certified personnel, and supervision and management of those personnel necessary to meet or exceed the agreement specifications. The resources may be used on fire suppression and all hazard incidents. Feller buncher or harvester. A feller buncher is a self-propelled machine with a cutting head that is capable of holding more than one stem at a time. The cutting head is used strictly for cutting, holding, and placing the stems on the ground. Feller bunchers do not have processing capabilities. Mechanical configurations. Either wheels or tracks propel feller bunchers. Tracked machines are slower than wheeled machines, but have the advantage of being more stable on steep slopes. Tracked feller bunchers are also capable of operating on wet and loose soils where rubber-tired machines would be prevented from operating. Feller bunchers may have self-leveling cabs that extend the slope on which they can operate. A swing boom feller buncher has the cutting head mounted on a boom. The cab can rotate 360 degrees so that it may sit in a location and harvest several trees. Felling heads are attachments built to be mounted either to a boom or to the chassis on a base carrier. There are 3 categories of felling head: bunching heads, processing heads, and felling heads. Bunching heads are designed to handle multiple stems and do not have processing abilities. Processing heads are capable of felling and processing trees. Felling heads are capable of cutting and felling single stems with no processing capabilities. There are 3 styles of cutting method employed by bunching heads: disc saw, bar saw, and shear. The gathering arms are similar to standard grapples and reach out to grab the stem being cut. A disc saw is a large steel disc with cutting teeth attached at the edge. A disc saw is also called a hot saw because the saw blade is always spinning. This saw is spun at very high speeds, in excess of 1,000 RPMs. The high speed and large mass of the blade allows these saws to cut trees extremely fast. Care must be taken when operating in rocky areas to avoid hitting rocks, as the sparks thrown may ignite the duff or wood chips. Another hazard is flying teeth when a tooth is broken off the disc. A bar saw is simply a large chainsaw bar mounted on the felling head. The saw retracts into the head when not needed. When it is needed, the saw bar rotates out to cut the stem. Bar saws have the potential to decrease the risk of fire starts but operate more slowly than disc saws. Processing heads are capable of felling trees and performing some sort of processing on the stem. The most common processing heads are capable of delimbing and bucking stem into logs. This is commonly referred to as a cut-to-length system. The main components of a processing head are a bar saw, delimbing knives, and feed rollers. The delimbing knives hold the stem while it is being cut and processed. The bar saw fells the tree and bucks the stem to length. The feed rollers move the stem through the head for delimbing and bucking. The delimbing knives have sharp edges designed to shear the limbs from the log while the stem is being fed through the head by the feed rollers. A dangle head processor is simply pinned to the boom. The head hangs vertically from the boom until the tree is cut. The tree then pulls the head into a horizontal configuration as it is falling. There is limited control over the falling direction. Some dangle heads do have hydraulic rams that control the speed of the fall. A fixed head is attached to the boom through a rotator and hydraulic cylinder. This provides the operator with control over the rotation and vertical orientation of the head, which in turn provides control over the direction and rate of fall of the tree. Bar saws usually have a greater single pass cut capacity, and while maybe not as effective as a hot saw in smaller timber or regen, and are a good option when dealing with large timber. Processing and felling heads excel when working in stands of timber that has fallen or blown down because it allows the tree to be cut from the root wad, lifted up, and cleared from the line. They also work extremely well when rehabilitating fire lines due to being able to pick up down wood and chunk stems into the existing fire line for erosion control. Operational considerations. Slope. Tracked machines with self-leveling cabs are capable of operating on slopes up to 55%. Tracked machines without self-leveling cabs can operate on slopes up to 40%. Wheeled feller bunchers should be restricted to slopes below 25%. Ground condition and tree size will affect the slope at which the equipment can operate. Rough, rocky, broken ground, or many ground obstructions will limit the slopes to less than the maximum. Larger trees also reduce the feasible operating slope because of the mass that can be handled safely. Soil conditions. Tracked machines have a lower ground pressure than wheeled equipment and are less prone to rutting and compaction. Tree size. Cutting head capacity and parent machine weight limit the size of trees that can be cut. Cutting trees at the limit of the machine may limit the ability to actually bunch trees and require one tree to be felled at a time. This will usually decrease productivity and increase cost of operation. Cutting trees larger than the capacity of the machine is dangerous to the operator. Increased slope will decrease the size of trees that the equipment can safely handle. Safety concerns. Feller bunchers are built with rollover protective structures, ROPs, and falling object protective structures, FOPs, to protect the operator. Care must still be taken when operating on slopes. Whether on flat ground or steep slopes, a large tree is very heavy and has the capability to tip a feller buncher. Moving with a load of trees increases the possibility of a rollover. Those working on the ground around feller bunchers should take care and heed the placards attached to the machines that state to stay back 250 to 300 feet. Ensure that a skidgen or soft track is available for suppression water. System interactions. Feller bunchers excel at felling trees and placing them in a convenient position for the extraction process. Since they do not process the tree, processing must be done manually or with another piece of equipment. The capability of feller bunchers to build and place bunches of trees makes them a good companion to grapple skidders, clam bunk skidders, and shovel operations. Drop tank skidder and skidgen. There are three types of heavy equipment with water: pumper cats, skidgins, soft tracks. Pumper cats are bulldozers that have had an engineered water tank attached to the machine in a manner that does not change the center of gravity. Pumper cats can be ordered in three different sizes. Type 1 is a large dozer equipped with a tank that holds a minimum of 500 gallons. Type 2 is a medium dozer that is equipped with a tank that is a minimum of 325 gallons and a maximum of 499 gallons. Type 3 is a small dozer that is equipped with a tank that is a minimum of 200 gallons and a maximum of 324 gallons. Skidgins. Skidgins are skidders or log forwarders that have had an engineered water tank attached to the machine in a manner that does not change the center of gravity. There are four classes of skidgin that are under agreement, with the Type 1 being a large off-road water hauler and the Type 3 and 4 possibly having a tank that can be dropped from the parent machine to skid logs as needed. Type 1 is usually a log forwarder equipped with a minimum of a 1,200-gallon detachable tank inserted between the log bunks. There are also skidders that have had their frames lengthened, heavier GVWR tires installed, and a tank installed where the log arches and winch were removed. They are the largest ground-based off-road water hauler available, 1,200 to 3,000 gallons. Type 2 is a large skidder equipped with a minimum of 800 and a maximum of 1,199-gallon tank attached to the parent machine. Type 3 is a medium skidder equipped with a minimum of 400 and a maximum of 799-gallon tank attached to the parent machine. Both the Type 3 and 4 may be classified as a drop tank skidder. Soft tracks. Soft tracks are machines that are equipped with a tank similar to a skidgin. What makes the machines different is that parent machine has a track that flexes over terrain, which increases traction. The weight distribution is very balanced due to the forward mounting of the powertrain and the machine's ability to carry the load or mount an attachment well forward on the machine. The combined weight of the vehicle and its payload is spread over the entire length of the tracks. They are capable of operating on very steep slopes of up to 55% and have a minimum tank capacity of 600 gallons. Skidders. A skidder is a tractor that drags material from the woods to a landing or roadside. Wheeled skidders are built on an articulated chassis with the cab and engine mounted on the forward articulation and either a cable drum and arch or grapple mounted on the rear articulation. Many modern skidders include both a cable drum and a grapple. Wheeled skidders typically have a small blade mounted on the front that can be used to push material out of the way and level small ground obstructions. Wheel or rubber tire skidders, RTS, are the most common machines to drag skid logs or felled trees off the line. Tires make wheeled skidders faster than tracked dozers and tracked banded vehicles, forwarders. They are better suited to patrolling fire lines or covering greater distances to support crews. These machines are articulated, so they work well in tight stands or on narrow trails. These machines have light-duty blades for pushing brush, slash, and light earth moving. They can also be used for putting in quick scratch lines, breaking up fuel deposits, and pushing small trees over. Rubber tires make them more stable on slide rock than tracked machines. Rubber-tired skidders are normally equipped with tire chains to increase traction. Mechanical configurations. Grapple or grapple with a winch. Skidders come with a grapple and sometimes a cable drum winch. A grapple is capable of picking up more than one stem at a time. A grapple machine with a winch cable has a skid line that can attach chokers and allow wood to be dragged up a slope or where wood is not easily reached with the grapple. Operational considerations. Slope. There are three factors that influence the slope on which equipment can operate. Safety. The safe operating slope at which a piece of equipment can operate without rolling or tipping. Gradability. The slope on which a piece of equipment can mechanically operate. Over this slope limit, fluids leak out of containers and the engine can no longer pull the load. Soil disturbance and erosion. The point at which either of these occurs is dependent on soil type and moisture levels and precipitation patterns. The slope on which skidders may operate depends in part on the direction of skidding. Favorable slopes where the load is being dragged downhill are preferred to adverse slopes, as this allows gravity to aid in the extraction. The slope guidelines given here need to be balanced with the type of soil over which the skidders are operating and the horsepower and drawbar pull of the equipment. These figures are based on gradability and do not take into account safety or soil conditions. Wheeled skidders. Favorable slope up to 45%. The ability of a skidder to turn safely is reduced when slopes are steep. Operational layout should consider whether the skidder can safely turn around on the slope. Broken ground that provides level benches on which to turn around may decrease this danger. Soil conditions. Due to the articulation of the machines when turning, skidder work in wet, muddy areas must be carefully planned using Stream Management Zone (SMZ) best practices. Because skidders drag the logs, soil disturbance is greater than extraction methods that fully suspend the load. Safety concerns. Grapple skidders permit the operator to stay in the cab during the skidding cycle. This provides an extra level of safety for the skidder operator. Grapple skidders work well with feller bunchers and harvesters. Feller bunchers are capable of building and placing full bunches in a manner that facilitates the productivity of the skidder. Mechanical configurations. Either wheels or tracks propel skidders. Tracked machines are slower than rubber-tired machines, but have the advantage of being more stable and having better traction on steep slopes. Tracked skidders are also capable of operating on wet and loose soils where rubber-tired machines would be prevented from operating. Rubber-tired skidders used in the Northern Rockies are required to be equipped with a grapple. Grapple skidders are usually paired with mechanized felling operations. The felling machine bundles the stems in a position for the grapple to grab. The operator need not get out of the machine to attach the trees to be skidded. This is the most common skidder type found in the West. Although the Forest Service does not solicit for tracked skidders, an order can be made to the dispatch centers for a dozer equipped with a grapple. Most, if not all, of these machines come equipped with a 6-way dozer blade. Tracked skidders are generally used where large loads are being pulled up or down steeper slopes, or where operations wants a machine that can help build fire line and landings. Tracked machines have more pulling capability per horsepower and lower ground pressure. Operational considerations. Slope, soil condition, and tree size. Rubber-tired skidders are restricted by the previous 3 conditions. Ground and tree size will affect the slope at which the equipment can operate. Rough, rocky, broken ground or many ground obstructions will limit the slopes to less than the maximum. Larger trees also reduce the feasible operating slope because of the mass that can be handled safely. Tracked machines are capable of moving larger bundles of wood up or down steeper slopes. Dozers. A bulldozer is a tracked machine that pushes material with a dozer blade equipped on the front of the tractor. It can also have a grapple, winch, or a set of rippers mounted to the rear of the machine. The grapple allows the tractor to easily drag material from the woods to a landing or roadside without the operator getting out of the cab. The ripper attachment allows the dozer to sink the shanks into the ground to loosen the surface material. A ripper is normally used to slow the descent of the tractor down a very steep slope during fire use. The winch is used to pull material up to the tractor or to be used to extricate the dozer or other equipment when it gets stuck or in trouble. Mechanical configurations. Type 3. Minimum 50 horsepower to 99 horsepower. Type 2. Minimum 100 horsepower to 199 horsepower. Type 1. Minimum 200 horsepower to 350 horsepower. Light dozers, Type 3, are effective in building fireline in light fuels on level to moderate terrain. They perform best in soil with few rocks and in wet soil conditions, especially when equipped with wide tracks. They are highly maneuverable in close quarters and generally leave less ground disturbance due to low ground pressures. They also can be very useful in mop-up operations. Medium-sized dozers, Type 2, are generally the best all-around size for fireline construction, as they are maneuverable and perform well on moderately steep slopes. They will handle the average fuel and terrain conditions in the mountainous areas. Heavy dozers, Type 1, are generally too big for many fireline construction situations. They are hard to maneuver in close quarters, especially in steep terrain. They are best assigned as lead dozers to pioneer in heavy fuels or working downhill in steep terrain. As a general guideline, dozers should not be operated across slopes, side hill greater than 45%, uphill on slopes greater than 55%, or downhill on slopes greater than 75%. Attribute that can be ordered: winch, ripper, grapple. If equipped, all winches must be able to rescue the parent dozer that it is mounted upon. Winches must have a minimum bare drum rating of the weight of the parent machine, plus 20%, and be equipped with a minimum of 50 feet of cable or wire rope minimally rated at this cumulative weight. Operational considerations. Slope. There are several factors that influence the slope on which equipment can operate. Soil disturbance and erosion. The point at which either of these occurs is dependent on soil type and moisture levels or precipitation patterns. Gradability. The slope on which a piece of equipment can mechanically operate. Over this slope limit, fluids leak out of containers and the engine can no longer pull the load, or the machine is incapable of maintaining traction. Rocks, fuel loading, tree size. Rocky ground is hard to gain traction on, and large trees or heavy brush limits the ability for the tractor to push the material out of the way. The slope on which dozers may operate depends in part on the direction of pushing. Favorable slopes, where the berm is being pushed downhill, are preferred to adverse slopes, as this allows gravity to aid in the line cleaning. The slope guidelines provided in the Fireline Handbook need to be balanced with the type of soil over which the dozers are operating and the horsepower and drawbar pull and weight of the equipment. These figures are based on gradability and do not take into account safety or soil conditions. The ability of a dozer to turn is reduced when slopes are steep. Operational layout should consider straight-down runs on very steep slopes. Broken ground that provides level benches on which to turn may decrease this danger. Six-way blades aid in production factors due to the operator being able to move the blade to needed angles to drive past trees, large rocks while constructing fireline. System interactions. Dozers are the original machine line builder. Dozers are used to access ground too steep or rough for wheeled machines. The most critical terrain hazards for dozers are side slopes over 40%, rock, unstable soils, stumps, wet areas, and boulders. Dozers with angle and six-way blades are used to cut fire lines, pioneer trails, and push over snags. Dozer fireline construction production rates are listed in the Interagency Fireline Handbook, including comparative up and down slope production rates. Most mechanized task forces include a Type 2 dozer for quick line pioneering, safety zone construction, and assistance with machine breakdowns. Dozers have faster track speed than tracked excavator type machines for emergency escape.